Hey, Miss Brown's class. So today we're going to go over random samples and how getting a sample of what's going on in one random group from a population can help us figure out something about a whole large group of what's going on. So what am I talking about here? Let's pretend that we have a situation where we work for a national park, okay? In this national park, we know that there are 600 bears that live there, okay? Now, it could be a scenario where we don't have time to go chasing down 600 bears. We really don't want to chase a bear. That doesn't sound like a good time. All right, maybe you don't have enough testing supplies, which seems to be an issue in America right now for humans. Whatever the case is, we were only able to catch and test 85 bears out of that total amount, okay? This is called the population, that's total. And the amount that we surveyed, or the amount that we tested, was 85 bears. This is called a sample. Okay, so if we were able to figure out that out of the 85 bears that we were able to catch and give a test to, 13 of those 85 were sick. So what we would say here is we would try to figure out what is 13 divided by 85. You will get a decimal answer. So 13 divided by 85, I get about 15%. All right, so that's equal to about 0.1529. Now, at that 15% rate of being ill, multiply that 15% times 600, but remember percent is written as a decimal. So that 0.15 times 600 bears, I'm just leaving the number I already had in my calculator, times 600. That came up as about 91.7. So it wouldn't make sense for me to say I expect 91.7 of the bears in this national park to be sick. I would probably round that up since the 7 tells me to go up. Make that equal to about 92 bears. So what this means is, based on the sample that I already was able to catch and learn about, I'm taking those results and then basically multiplying it out towards the whole population, okay? This is going on largely right now with what America is experiencing through this whole pandemic, okay? We have not had time to test 350 million Americans, okay? We've tested about 1% of them, and out of those people, we're able to get a bunch of data, okay? At first, they were saying, it looks like this illness is only affecting senior citizens. But let's think about this word random. The first couple of weeks of our testing in America, a lot of sites were limited to testing people who were 65 or older or who worked in healthcare. So is this a random sample of people, or is that a specific targeted group? Okay, that's not random, okay? They told you can only come get tested if you fit this criteria. In this case, with our bear problem, I didn't specify anything about what bears I was catching in order to do this illness test, so we'll assume it's random, okay? Anytime a question is presented to you and you're trying to gauge whether it's a random or biased means that they're kind of picking sides. If you're trying to figure out if it's random or biased, you have to think to yourself, well, did they mention any restrictions? So, was it only people of a certain age? Is it only male or only female? Is it only within one geographic region? So did they say we're only going to test people who live in Florida, or are all 50 states doing tests? Okay, you need to look at all these things and see if there's a sampling or if they're taking people from all categories. That's what you're looking for in random samples, okay? But you will have problems where they ask you to multiply it out to equal to equal what you think will happen for a total population. Let's do another example like that. All right, as many of you guys know, in high school I used to work for a Hallmark store. We sold useless things such as statues and figurines that sit on your shelf and collect dust. Now, since that was my job, you can imagine we didn't have tons of customers, and we had time to sit there and check in 80 statues and check to see if they're broken. However, the companies that were shipping these out were shipping it to hundreds or thousands of Hallmarks all across the country. So do you think that the makers of these useless statues and stuff were able to check thousands and thousands and thousands of their figurines? Probably not. Okay, we had the time to at my individual store, but that's only because we were ordering a few dozen at a time. So what the makers may want to do is they may want to check a random sample to see how likely it is that their product will be broken during shipping or at any process to figure out, should we wrap it in styrofoam, should we put it in bubble wrap, how should we protect it? So I could say that a company is going to ship out 2,000 figures. Out of those 2,000 figures, they found that 43 were broken. Or sorry, I skipped a step. We checked 400. A sample is a smaller group than the total, okay? So total is called population. And sample is the smaller group that you checked because you didn't have time to check 2,000 of them. So if I checked 40 of these figurines from my sample, or I checked 400, and it turned out that 43 were broken, I want to do the same thing that I did with the bear problem. I want to divide. I want to see what's 43 divided by 400. It should be close to 10%. So 43 divided by 400. So I got 10.75%. Remember, as a percent, you write it as a decimal, so 0.1075. I can take that percentage that I got and multiply it by how many total I have. So what's 0.1075 times 2,000? I often suggest just saving the answer in your calculator so you don't have to keep typing it. So times 2,000. So you're expecting about 215 broken statues or figurines, whatever they are. Now, you may think to yourself, why would I ever need this in life? Okay? Well, this company knows there's always a chance when shipping that things could get broken along the way, right? Okay, so if they're getting 200 statues returned to them for being broken, if they're getting 220, all right, that's about what they expect with their 10.75% breaking rate. However, if I call up the company and I say, hey, I had like 80% of my statues broken and I want to return all of those and get my money back, is that 80% rate of broken product close to that 10.75? No. So you kind of want to have that number in mind because you would want to know if you're working for some sort of company and you're ordering products, you want to know, okay, about how often do I expect to return? How much cash should I have in case I need to give money back to a customer? Okay, so it gives us an idea of what to expect. Maybe we know that instead of making 2,000, maybe we need to make 2,200 to make up for the extra ones that are broken. Okay, so these are all things that we would need to consider, and it plays into a big part of marketing and owning your own business, okay? Also, car retailers need to know this as far as their safety equipment, okay? But you would hope that cars are not messed up 10% of the time. That would be a really high rate. Safety requirements for vehicles are far different. Okay, so random samples. This would mean these 400 that I just randomly picked out and I wanted to check, were they all from the same box? Were they all from UPS? maybe I should take one box that was shipped with UPS, I should check another box that was shipped with FedEx, and I should compare the two and see if they have different rates, okay? If it's random, then they can't all be in the same exact category. They have to be chosen from different areas. So make sure random sample means that it's a little bit from everything, okay? And with these figures, maybe pick some that have different shapes so it's not always the same design that you're looking after. All right, so that's it for random samples today.